Okay, let's have a look at some features. For example, the pathway of Antarctic bottom. Okay, this is the near bottom potential temperature in the Pacific Ocean. Okay, and you can track the pathway of bottom water from the coldest water that you can find. Okay, because you can imagine that you have a source of cold water. Okay, so this is water coming from slope convection, formed in shelf seas and so-called polynyas. It ends up somewhere at near the bottom and then spreads. And during the spreading, it can only warm up because it entrains, it mixes in warmer water. Okay, essentially from above. Okay, because it moves along the bottom. And then you can identify the pathway, because all you need to do is you need to connect the regions where you have the coldest water. Gives you the center line of the flow. You can see this flow here. The Antarctic bottom water moves more along the western part of it's very sluggish, very slow circulation. What's also shown here are the regions shallower than 3,000 meters, so-called ridge systems that I referred to before at the beginning of this lecture. And you can see that there's sort of a separation of the circle. Okay, let's have a look at the intermediate water. Oh no, there's something. I forgot something. I'll show you that again. The deep water cannot identify it in large parts of the Pacific Ocean. And I'll show you that slide again. This is one slide that I discussed in detail in the lecture on the deep circulation of the ocean. And you can identify or follow the pathway of North Atlantic deep water from the North Atlantic Ocean, it's shown here on the left, okay, through to the North Pacific. And this water cannot clearly be identified through a salinity maximum at depth in the North Pacific, but indeed it leads to mixing mechanism also as a signature. In the North Pacific, even the oxygen content at depth is still sufficiently high to maintain most life in the deep Pacific or deeper water. Okay.